So good morning, ladies and gentlemen. My name is Dario Trabucco, and I'm together with Yasser Mahmoub of the Doha University, the chair of the next session on sustainability. We are afraid to inform you that we're running 25 minutes behind scheduled time, so we have to cut a little every presentation. So we're going to just leave 18 minutes for the presentation so as to have some question and answer time at the very end of the whole session.
Good morning, everyone, and thank you very much for coming directly from the morning speakers. And I believe this will be one of the most successful sessions of the conference. All the presenters have very interesting topics to present, and they're all very well informed and experienced in these areas, and they all have the theme of sustainability, but also they are all focusing on the issues of geometry, design, geometry, and responsiveness and typology. I think all the presentations will bring up issues that we are all hoping to hear about. Our first presenter will be Philip Vivian, and he is going to talk about tall, green, and subtropical. In his presentation, he will be talking about Smart 111 plus 222 is a mixed-use development in Brisbane. Philip is a director of Bates Smart, based in Sydney, Studio, Australia. He is a registered architect and urban designer with 25 years of professional experience. He obtained his Master's of Science degree in Architecture and Urban Design from Columbia University in New York in 1991, after his Bachelor of Architecture with honors from University of Western Australia in 1987. So we'd like to welcome Philip to the stage to present his paper.
Thank you. I'm going to go quite quickly because of the time limit. So this talk's called Tall, Green and Subtropical. It's about a building that's planned in Brisbane. It's going to be the tallest building in Australia, but importantly it looks at being a sustainable building from a subtropical point of view. It's a mixed-use building. It has a hotel, office and residential, which are three of the sectors that Bates Smart specialise in. Many of you might not know our work, so a quick summary. This is Crown Metropole, the 600-room hotel that was completed last year, a series of hotel interiors by our office, a series of residential projects completed or under construction, and a series of commercial office buildings by the practice. So we specialise in those three areas. So Brisbane, it's a subtropical location on the east coast of Australia. That's the city of Brisbane. It's on a bend in the Brisbane River. That shows you the bend. It's got on the botanical gardens in the foreground. And our site is shown in that red area there. It's surrounded by the key tourist and office precincts in the city, so it's quite central. It's very well connected by road transport, and the orange line going across is a new cross-river rail project to be constructed over the next 3 years. And that cross-river rail project has a two station entries, 50 metres either side of our site, so it'll be highly connected to public transport, which assists it. It's a regeneration area. The site is shown there in red. It has spectacular views both to the northeast and southwest up and down the Brisbane River, as well as to local landmarks in the Brisbane area. That's showing you the views at the mid-level and views down the river from the high level. So when we approached this project, we wanted, as an iconic tall building, we wanted it to relate to its place. So we started by looking at the city And we looked at the city grid and how it sits adjacent to the Brisbane River. And we thought if we could capture these two things in our design, we'd actually embody it in its location. It would have meaning beyond just being simply a tall building. So we abstracted those two systems into a river edge that was natural and flowing, and a city edge which is hard, urban and straight. And we put those on the site and said, well, if on the river side we could have a flowing edge, and on the city side a hard urban edge, it would start to talk to the city and its location. The riverside had the residential, which, as I've already mentioned, had the views diagonally up and down the river. The commercial side was on the city, had views directly to the north, which is on the right of the screen. So we arranged the program very simply to correspond to those views. And that neatly corresponded with our soft flowing edge and our harder urban edge. We then put cores in these two buildings. And there was additional residential on the back of the residential building, making it a central core building, whereas the office building is a side core building. Of course, there are views out required from those residential units, which ultimately resulted in the scalloping of the commercial building to allow the views out. And you can see the core at the back of the commercial building provides privacy to the adjoining residential. That shows the two floor plates in their relative juxtaposition. At the narrowest point, they're 7.5 metres apart. You can see the core of the commercial providing privacy to the residential units. The design of the tall building, which is the residential building, evolved from an equilateral triangle. We were interested in its as an iconic building in its non-directional nature, so whichever way you viewed it from, it had the same view. It was also highly structurally efficient and stable. We curved the corners to create a more compact form and remove those difficult to plan corners on a residential. And then we gently curved the outer edges, which assists with wind shear and also maximise the apartment views. The building, the typology of apartments and hotels is based on a modular system that works with the structure. The smallest module at the top is a hotel room. 1.5 of those modules is a one-bedroom apartment. 2 modules is a 2-bedroom apartment. 2.5 is a 3-bed, and so on. So it gave a high degree of flexibility for the developer to vary the product that he was offering as the building went up. So the low-rise plans, levels 5 to 21, is a hotel, 22 rooms per floor. You can also notice the maids area at the back, providing privacy to the adjoining building. So that shows the location of the low-rise. There are 22 floors, 369 rooms. It's a 5-star hotel, currently in discussions with operators and owners. The low-rise residential is predominantly 1-beds and studios, as shown on this plan. As you move up the building, it becomes increasingly 2-beds, 70% 2-beds, and at the sub-penthouse level, predominantly 3-beds. And you can see all of those units working very neatly with the structural module. In summary, there are 65 residential floors and 793 apartments. And that's a perspective of the residential building from the street. The commercial building, the low-rise floor plate, approximately 1,100 square metres per floor over 17 floors. As the low-rise drops off, we get a very open, contiguous floor plate in the high-rise, which is highly desirable, particularly in the Australian market. 1,200 square metres net per floor. In summary, 37 floors of commercial, 49,000 square metres gross and 35,000 square metres net. And a perspective of the office building with the residential tower in the background. And I think you can see here how the commercial building has a much harder urban edge to this more urban streetscape. A summary of all of those plans, just showing them in relation to the height of the building. Statistically, the building is going to be 300 metres high. There's 92 floors in the residential tower, 37 floors in the commercial tower, and 8 floors in the basement. Environmentally, the residential building aims at a 4.5 star neighbours rating and the commercial building a 5 green star rating. In section, I'm jumping through some of these due to the short time limit. There were various studies undertaken to establish the final height with the developer. They were always very keen for it to be just over 300 metres, so it would be the tallest building in Australia. And that shows you its relationship to other tall buildings in Australia. The Eureka Tower is probably about equal tallest with what's planned at the moment. This is actually a cartoon from one of my children's books, but it neatly captured for me the way we feel in Australia, which is we generally feel a little bit small, but occasionally when we climb up high, perhaps on a rock, you get to feel quite tall and quite happy, as we do in this case. However, that jubilation is fairly short-lived as we look at our project amongst other high-rise buildings around the world, and we realise at 300 metres, sadly, we are really quite small. Now, in terms of the facade, we did a lot of studies on, these are views from the sun taken at the summer solstice. One of the critical issues of this building is it has a lot of facade facing the low-angle east and west sun, which required a lot of effort. So we studied it during summer, during the equinox, and I think you can see the amount of that tall building that gets a lot of early morning and late afternoon tropical sun, and in winter. And on a facade-by-facade basis, and this is just for the residential building, we studied the heat impact and also the angle of the sun to understand the shading that would be needed to make this building operate. We were also interested in the facade not just purely performing but relating to its subtropical context. So we looked at tropical plants in the sense of that layering and repetitive nature of those plants and the modularity and even the farming practices. We also looked at tropical vernacular, the idea of layered roofs that allow structures to shed rain and also to breathe in the tropics, as well as the local Queensland vernacular, which has developed a series of screens for the glare, the intense tropical sun up there, and on the lower right, the idea of small elements that shed rain from windows from those heavy tropical downpours. And we put those together and we said, look, our building has a lot of low-angle sun, so we might need something vertical to cut out that low-angle sun. As a residential building, we wanted to protect the openings for tropical downpours so that we could have windows that open, and we were also concerned at glare from that low-angle sun. The building also had various conditions. At the top it had balconies for residential, it had winter gardens, which are ventilated balconies, and also enclosed spaces. And we didn't want these requirements to overtake the aesthetic of the building. So when we put all of those requirements together, we came up with a layered shingle-like approach to the facade, where each layer overlaps the layer below. The bottom part of the glass is fritted to provide solar protection, and as it overlays, it allows windows to open, it sheds water from the building, and provides an amenity to the occupants of this building. It's also a floor-by-floor system. And that shows you a close-up of the system. You can see the fritted glass at the bottom that provides the shading, and the subtle scalloping that gives it an organic, slightly leaf-like quality to the building. This is a BIM model of the facade that's been developed. There's been a lot of study on these modules to get the geometry exactly right. All of the modules are identical as you go around this shape, so it's a highly economical facade system. Very quickly on the commercial, we did the same analysis for the commercial building, studying the heat loads. Basically, the east and west facades have the same conditions of that low-angle sun requiring a vertical shade in a frit, but the north facade, the straight facade, faces directly north and is best protected by a horizontal sunshade. We've also introduced a light shelf internally to bounce light into these floor plates, because on this side core arrangement we end up with quite deep floor plates. You're looking at a floor plate there that is approximately 26 metres deep from the front wall to the core. And that shows you the resolution of those two facade systems as they meet at the corner of the building, the overlapping shingles and the horizontal facades to the north, both providing different solar protection due to their orientation. In terms of where it sits on the site, we have a separate lobby at either end. There's a commercial lobby fronting Mary Street here, and a porte cochere, an entry for the residential and hotel lobby on the other street. There's also a direct through-site pedestrian link linking those two streets in the site. Ground floor plan showing the commercial lobby picking up on the geometry of the building above, the porte cochere entry to the car park. The commercial building has its own entry to the car park. Lobby here for residential and hotel, and the pedestrian through-site link. A view of the commercial building with its lobby on the street and looking down the through-site link. It's a pedestrian-scaled through-site link. It's 4 stories, open to the sky, so it gets a lot of natural light. The idea is to get restaurants in there and really activate that through-site link. And from the other street, the base of the hotel and residential tower, on the left you can see the raised porte cochere entry. There's a podium structure for the hotel, and on the right you're looking down the through-site link. 5 minutes, okay. And a view looking down the through-site link from the residential hotel end. Importantly, we've looked at renewables on the buildings, really harnessing the power of the sun and the wind. The commercial building, as I mentioned before, faces directly north. We've angled the roof so it can maximise the solar access on the roof. And with the tall building, we're utilising the power of the wind. There's no other structures around, so it's got a clear access to the wind. So we're looking at photovoltaics on the roof of the commercial building as part of our Green Star analysis. And on the top of the building, we're looking at wind turbines. The triangular shape has great access to wind from any direction, so that's going to generate power for all the public spaces in the building. The building has been wind tunnel tested. That's a wind tunnel model. And really we've achieved a major reduction in the structural capacity of the building. I think it's about a 30% reduction in structure due to the shaping of the building, both its triangular geometry and its curved nature. Structurally, the primary dead loads are taken down in the perimeter columns, which you'll see are actually pulled back 2.5 metres from the facade. That basically allows maximum views. When you approach the facade, there's no columns in the way. That cantilever also helps balance the back span. There's a primary tube structure for the lateral restraint, and due to its height, there's a series of outriggers and belt trusses that give it stability on the way up. And actually Ryan Campbell, the structural engineer from Bonacci's, is here. If you have any structural questions, I'm sure he'd be happy to answer them. That is a composite of the structure, and just showing the structural BIM model, the belt truss on the left and the lateral stability elements with the outriggers on the right shown in red. And showing the structural model, its deflected and torsional shapes as it's being developed at the moment. And structurally the stress diagrams and axial load diagrams under a lateral load. And this is a composite of the structure. Interestingly, you'll see at the top the two elements, the blue elements are displacement tanks. We've just found out from the wind engineer that the building's operating so efficiently that we don't need those displacement tanks. Plant rooms are distributed top and bottom in the commercial building and throughout the residential tower. And if I've got time, I'll just quickly cover some of the engineering aspects. Mechanically, the commercial building is a low temp VAV system. with centralised chillers and an air handling plant in the low and the high rise. The residential tower again has centralised chillers but localised air handling units in the apartments and the hotel rooms. Electrically, the whole complex has a shared substation, an HV switch room in the podium, and there's a gas-fired tri-generation plant that is incorporated to reduce peak energy demand. And from a lifting point of view, the commercial building's using destination control lifts, 5 in the low-rise, 5 in the high-rise. The hotel has 3 lifts, and the residential low-rise 3 lifts, and high-rise 4 lifts. And we're just currently undertaking a study of using twin lifts, 2 lifts and a shaft, for the low and mid-rise in the residential. Diagram for the combined services in the building. And just to finish up, looking at some views of the building. The building's currently in for planning approval. We're getting planning approval on October the 18th. The excavation is actually dug. So we're down at 22 metres, and it's currently being pumped out. You might be aware there were floods in Brisbane earlier this year, quite devastating floods, so it's being pumped out, and construction's due to commence in November this year. List of all our consultants. Of course, none of this would be possible without a great team of consultants, and we've certainly had a great relationship both with the dual developers, Bill Berger and AMP, and all our consultants. Thank you very much.
Thank you for finishing on time, exactly, and that will give us a chance to have questions at the end of the session, so please write down your questions, and we'll leave all questions until the last 10 minutes of the session. You're going